Would you mind just standing up for me and joining me as we welcome to the stage from Booz Allen Hamilton, Josh Boyd.
Thanks.
Thanks.
So I'm Josh. I'm going to be talking about microservices, containers, and mostly on the monitoring side. And then kind of, first we'll talk about how we're using them. So this is me. Well, that's my kid over on the right. I just learned about this trick in PowerPoint where you can put animated GIFs. So that's him in his bounce house. So I've been a software engineer for 10 years, I guess, before I came to Booz Allen, where they hired me as a software engineer, and then I stopped writing code. So that's kind of neat. And I started running basically platforms, operations, things like that. I started off kind of in startups and digital marketing agencies, things like that. These small places where it ends up the guy who's writing the code is also the guy who's running it in production. So it was like DevOps before DevOps existed, right? So I also did some, open source things as a core contributor to Drupal, did some PHP work. This little faux trade thing up top is where we were Flickr before Flickr, and we didn't have funding because of that. And then OpenFISMA was this first large open source project I worked on for the government, where we did FISMA compliance for the government. So what's this project about? So the General Services Administration has a series of sites, 10 of them actually, where they're doing basically awarding grants and posting RFPs and bidding on proposals. Contractors do. So this is where all the government contractors go, bid on things, get awarded contracts, and then money gets awarded, right? So the specific area where our project is centered is in the integrated awards environment. So these are sites like sam.gov, CFDA, FBO. Wow, those are bright. How those contractors get awarded money and how we run those systems. So these systems are legacy systems, and not only are the systems siloed, all 10 of them, but then the organizations that run those systems are siloed as well, right? So you've got your development teams, your operations teams, your security teams, your business units, all operating independently, all running these 10 systems independently that also have to kind of work together at the end of the day. So it's not so great, right? And this is kind of what it looked like 4 years ago and still kind of does today. So all of these applications have their own load balancers, their own API management, their own sources of user data, right? And their own databases. And they might be using Oracle, they might be using Postgres, they might use MySQL. Who really knows, right? So that's not so great, right? Especially when all these applications use the same underlying data. So what do, right? We destroy the silos or try to. So how do we do that? So we came in with a microservices type architecture. On one side, these application teams are writing using Docker containers. Well, speaking of which, how many people are actually using Docker? Can you just raise your hands? How many of you are using Docker in production? Less hands. And are you running more than one team with Docker in production? There's like 3 people. Okay, so we have 6 teams running Docker in production. Well, next month it'll be these applications in production, right? But for the last 2 years, we've been running our platform in production for all the developers who are developing these rewritten applications, busting these silos, and writing implementations in microservices. So what's this look like? We were tasked with writing a common services platform, right? So these things at the top, these applications with business logic, are all rewritten greenfield development with containers, specifically on Docker Data Center, right? Except when we started this project 3 years ago, Docker Data Center didn't exist yet, right? So you had Docker Engine, and well, you had Docker Engine. And then we kind of followed the progression of using the upgrading every 6 months to the newest version of Docker, and then getting it to Docker Swarm mode, then Docker UCP, and now Docker Data Center, the all-encompassing tool from Docker, right? And then underneath, all these things that were in these silos, those are all shared now, right? So we offer these common shared services for all the microservices to consume, right? And so they're all kind of speaking the same language. It makes it so that when you're onboarding new applications, new microservices, it's much easier because everybody's speaking the same language now. And now your application teams don't need to think anymore about all that stuff underneath, right? So now all I care about is my container and my application. I don't care about what version of Linux I'm running, what cloud I'm running on, if I'm running on a cloud or a private data center. I don't care about what user store I'm using, because all of these are done through APIs. Right? So our solution was, at the core, Docker and Docker Data Center. But of course, Docker isn't going to give you all of those common services that you need, right? And Docker isn't going to necessarily give you what you need to run in production to be able to monitor, log, do security alerting, all those kinds of things. So this is 80% of the tools that make up kind of the common services platform that we've built, right? And I'm sure you all are familiar with how large the landscape now is surrounding Docker and containers in general, right? So we're using public AWS, we're using Red Hat 7, we're using GitHub, we're using Elasticsearch, Chef, Sysdig, Kibana. All these tools kind of combine together so that we can, one, support our developers as they're developing their applications, two, support those as they go into production, and then three, provide all those common services and have the operations teams know what's going on and be able to run those systems. So, Sensu. We kind of go down the path of, so we started 2 years ago figuring out how do we do monitoring, alerting, logging for our system and then for developers, right? So we started with Sensu. And Sensu is great for operations, right? I can write my checks as code, I have all these clients, and it integrates with all my alarming and alerting systems. So that's really cool. But when I'm running applications now, does this mean when I have my separate teams that I run separate versions of Sensu for every team, and then they write their own checks so that each team doesn't find out about all the other monitoring tools and all the other processes, right? Because in government, we often have this separation of duties where different teams can't know about other teams' data, right? So we didn't really go down that route because we started to and then thought about it, and it wasn't going to work out so great. But Sensu works really well for monitoring our 500 instances that power this whole system in production, right? So then we have logs from all of our platform and then our containers, right? So we use, like most everybody else, we use the Elk stack with kind of Redis as a queuing backer. So we can use the Guelph endpoint with Logstash and feed all of our logs with Docker Data Center into our Elasticsearch cluster. And then all of our logs are there, and they're kind of formatted most of the time kind of nicely until you get this massive Java stack trace, and then you have to mess around with Logstash, right? But in general, you can see your logs, you can create dashboards out of your logs, right? And that's pretty okay. But then again, how do you separate out your logs based on your teams, right? So I want to make sure that my web front-end team isn't looking at my DB tier logs, right? Because it's just going to be extra data that I don't really need. So in Elasticsearch, we end up using, Elastic has renamed it now, but it's part of the XPack. We use Shield. So we can use Shield to integrate with our LDAP backend or our LDAP groups, and then we can say these kinds of, we have these fields on there like container ID, we have container name, and we have Docker stack names and things like that. So we can filter with basically regular expressions on the queries as they come in to say that your group can only look at indices or queries that have these pieces in them, right? So if you're the web tier and your stack name has web in it, then you can go and look at those and not see anything else, right? Problem solved. Logging taken care of. But logging isn't so great, right? Because logging is reactive. So when something happens in production, I go and look at my logs, and I see where the bug happened, right? How often do you actually able to look at your logs and then go reproduce that bug in production and development? Like, how many of you have ever been able to do that? Like, reproduce every bug you've seen in production back somewhere else? Like, it doesn't happen, right? Like, you're lying. Like, this is not true. Or you've been doing this for like a week or something. Like, I don't know. You've been lucky. Right? It's not feasible to be able to go look at logs or generate so many debug logs now that I can go and find exactly like, oh, this is what happened, and I know why, and I can fix it, and I can reproduce it. So how do we go about doing this proactively? So proactive monitoring, we kind of looked at some different tools, and we ended up using sysdig. So one of the tenets of our platform, if you haven't noticed, is kind of an open source first model, right? There's no commercial tools laying around in there. Now, there's open source tools with enterprise enhancement and support, right? But these are not pure commercial tools that we're using. So sysdig lets us do things like Sensu kind of does, right? Where I can monitor for things, and if they go out of the bounds of what I expect, then I get an alarm. But the difference with sysdig is that I can capture all of the events within a time frame around that event, right? And it's looking at my entire system. So sysdig is this container native monitoring platform that hooks in at the kernel level. So it listens to all the syscalls and is able, with their security tool, to intercept all the syscalls and do something about it. But because I'm operating at the syscall level with sysdig, I can see everything that's happening now. So I can see CPU, I can see memory, I can see network, but then I can see all of the metrics from, so if you instrumented your application with statsd, all those get picked up too. If you don't instrument your application, all the JVM stuff shows up. And there's built-in kind of filters for picking up all of your MongoDB data and your Postgres data and all this, right? So now I don't have to, like some other tools, instrument my application and write all the monitoring things that I care about. So that's really cool. The other part that's cool is the alert thresholds. I don't have to go and manually set that for everything, because now that I'm looking at the syscall level, I have thousands of metrics that come out of the box. And I have no idea what 3/4 of those metrics, one, what they mean, or two, like how to measure like when that's bad, right? So what happens is I can do this kind of statistical analysis in sysdig where it looks back at all of the historical data and says if I'm more than like a standard deviation or two above or below what it's always been, then I start throwing alarms on that so that I can start, I don't have to understand my entire system, and once we get moving along, I can identify what things are important, right? So I'm going to show you, I've got to exit the deck to show you kind of the demo of what I'm talking about. And the important part here, which is teams. Can you all see that? Cool. So here I am logged in as like a platform administrator, right? So these are, I'm looking here at my swarm. So I've got my my services. All of my swarms all of my applications are created as services in Docker Swarm, and so I have stacks and they have namespaces, right? So these are all named, right? So I'm running capital ones, Hygeia dashboard, DevOps dashboard in there. I've got Jenkins and SonarQube. I've got a Kibana proxy running, so I can use AWS's Kibana without having to do weird whitelisting. And then I've got this some sample applications running in there. So this is all really cool, right? Like I can drill down, I can see what's running in my stacks. But how do I like share this with other teams? And how do I make sure that other teams aren't like digging into all of my AWS stuff or my other resources? So I can kind of narrow this down by different teams. So when I create a team in this tool, go look at one. So I can scope what my teams look like. So I can look at the swarm stack names, right? And then say, I want my CI/CD team to look at SonarQube, Jenkins, and Hygeia. So when I become that team, sometimes, Let's try another team. This is the joys of live demos. I didn't pray to the demo gods. There we go. Hygieia team, right? So here's the Hygieia team, and here's all of the containers that are specific to just my team. So I can see what's going on with them, and then I can drill down into these things. And I can see network connections, file system stuff, I/O, and really drill down into most anything I would ever want to know about my containers, right? And then I can make my own dashboards and things like that. So when I go and look at a dashboard, right? So now I can see these are all of the connections for Hygieia. So I can see all of the network traffic that's happening just specific to that application. So rather than having to go through and look at my VPC flow logs and figure out like what host that maps to and where I'm scheduling my containers, I can just go directly to this tool and see what's happening. And so this is like an enterprise front end to the open source sysdig tool where you can go to sysdig.org, download the tool, and you can do investigation of all this stuff from the command line without Teams. So when I look at this, so that's cool, and I look at the network traffic. All right, so this is even cooler, right? So now I can see all of my microservices, or all my services, all containers, talking to each other, what traffic is going between them, right? All because I'm listening at the syscall level. And all these are living on different hosts within the Docker cluster, right? And they can even be living in different data centers or regions or whatever you want it to do here. And then I can get information about each of these and learn what images I'm using and things like that. So dashboarding, right? And you'll notice that the dashboards are now segregated based on teams. So my admin dashboards had a whole different set, and my Hygieia team has a series of dashboards that are specific to them. But this also happens for alerts. And so I can configure all my alerts, right? And these are kind of the built-in, out-of-the-box ones. So we can see we've gotten some notifications like a low container count warning, so maybe I expect there to be more than one. And then I can see like all these warnings happen. So my operations team doesn't care about my team's application, right? They care about the platform itself. So now my application teams can get the alerts that matter to them and not have to go and create a ticket and request it and have it built for them. They now have complete control over this themselves. And then this integrates with other tools like PagerDuty or whatever your alerting items are. So we can see those here. And then as I drill down like to a web application that's got multiple containers running the same service, I get the same kind of deal going here. So I see all my front ends replicated globally across my cluster. I'm glad it worked that time. It didn't show me the admin view. And then the same type of thing, except now I know I have, this is a web app, right? So I want to see all my web-related request information. So here I can see for my application, if this wasn't a demo environment and I was testing it, right? I would see all of my slowest URLs. So right now it's the status URL, because sysdig starts that. But you can drill down into this and see like, oh, my shopping cart checkout routine is very slow, without having to instrument anything in my application. And you can alert on all this stuff as well. So if you wanted to alert on your status code, so if I started getting 5x or 4x status codes, I can alert on that here too. So this has been really powerful for our teams. We're rolling it out now, the team integration with all of our application teams. That's not an interesting screenshot at all. Right, so we're rolling this out to our teams now because what happened previously was their application went down in some environment, right? So they'd go and look at their logs, and their logs just said, oh, there's an exception, right? But it doesn't really help you, so we go back and tell them, hey, turn on debug mode in all of your logs, and then they try to reproduce it and it doesn't work. So we started using this tool, and we're able to drill down and see, because it captures when the alert happens and captures the events around it, so that when an event happens, it captures everything within the platform, right? So not just your Sonar Cube container, which is a bad example, but also all the containers that are around it and connect to it, and even the hosts that connect to it, right? So all of your database traffic, all of your web tier, all of your load balancers, all this information, you get a snapshot right when your alert went off. So that I can go and see, oh, look, memory usage spiked on my load balancer and then started dropping traffic, so I don't need to investigate my application anymore. Rather than being kind of left in the dark and drilling through logs for every single piece of the platform that we have. So that's the demo. I wanted to leave some time for questions. And then I have one more slide. Maybe. Yeah. So that's our taco truck, the Booz Allen taco truck. It's our recruiting truck, but I really wish they'd sell tacos. I keep telling them they'd have better luck if they sold tacos or gave them away. But yeah, that's Barb, the Booz Allen recruiting bus. So if you see it around, walk up there and you'll run into my recruiting friends. And we can talk about what we're doing with DevOps and platforms and containers and all that kind of stuff. Thank you.
All right. Let's hear it for Josh.